Hey everyone, so now that we've gone over like all the reactions of alkanes, alkenes, alkyl halides, and alkynes, let's look at some synthesis approaches. Okay, so these are like some things that would come in handy as you're approaching a synthesis problem. And I've sort of like uh, categorized them depending on the reaction that we're doing. Okay, so let's start with an alkane to an alkene. How would you convert an alkane to an alkene? Now, sometimes in synthesis, you might be thinking backwards, which is called a retrosynthetic approach. And in this case, instead of thinking about making an or converting an alkane to an alkene, you're thinking about, okay, how do I make this alkene from an alkane? So it's the same question, but you're thinking in the reverse direction. So let's start off with something simple. So let's say if we have an alkane like that, and if I want to convert it into an alkene there, so the approach that you take or the sequence of steps that are usually involved in this sequence, in this entire sequence, is first to do a free radical bromination on the alkane, because again, recollect that the only synthetically useful reaction of alkanes that we have learned so far is the free radical bromination. So if I do a free radical bromination on that alkane, it would give me an alkyl bromide. And now that we have an alkyl halide or an alkyl bromide specifically, we know of reactions that can convert an alkyl halide into an alkene. That will be an E2 reaction. So since I have the alkyl halide, what I can do is I can react it with a strong base. And this reaction is usually done in a polar protic solvent. And so when I do this, I'm going to make this alkene. Now, important thing to notice here is that this alkene that we made is the more substituted alkene that's possible. Okay, that's the more substituted alkene that is possible here. We could as well react this alkene with a bulky base, so potassium T-butoxide, and in this case you could use T-butanol as the solvent, and then we would have made the less substituted alkene. Okay, so the less substituted alkene would have been our product. So that means to go from an alkane to an alkene, you have to first sort of figure out if you're going to the more substituted alkene or the less substituted alkene, because the choice of reagents is very important. Okay, so let's try it out. Let's say if we have an alkane, and if I want to convert this alkane into an alkene here, okay, what I notice is that compared to that alkene, this alkene seems to me like the less substituted alkene. Okay, now it may be hard to tell right away, but whenever you have an alkane, the first step to do is the free radical halogenation. Okay, so you go ahead and do the free radical halogenation. Now the free radical bromination is a selective reaction, so the bromine ends up on the more substituted carbon. Okay, and now that you have the alkyl halide, notice that from this alkyl halide, starting from this alkyl halide, this is your alpha carbon. You have a beta carbon here, and you have beta prime carbons available. And the alkene that you have or the target alkene has a double bond between the alpha carbon and the beta carbon, and the beta carbon here is the less substituted carbon. And so that means to complete this synthesis, I'm going to use a bulky base, potassium T-beta-oxide, because when I do that, that would give me that alkene as the product. Okay, again, to always go from an alkane to an alkene, you are converting the alkane to an alkyl halide and then doing an E2 reaction. That's the key. Okay, free radical halogenation followed by an elimination will give you an alkene from an alkane. Now let's look at some synthetic strategies or synthetic approaches where you can convert a more substituted alkene into its less substituted counterpart. And we have some examples here, so we'll just go with that. So let's say what I want to do is I want to convert this alkene to its less substituted counterpart, which is there. Okay, we just made both of these alkenes from the alkyl halide. Okay, so whenever you have this problem where you're trying to go from the more substituted to the less substituted alkene, okay, the approach or the strategy is to first do a hydrohalogenation on this alkene. So if you do the hydrohalogenation, I will convert that alkene into an alkyl halide. Okay, so I go from the alkene to the alkyl halide. And then if I react this alkyl halide with a bulky base, that will give me the less substituted alkene. Okay, now what if I wanted to go from the less substituted alkene to the more substituted alkene? Okay, so if I started with the less substituted alkene, and if my target is to make the more substituted, so this is the less substituted alkene, and we want to make the more substituted alkene, what we'll do is we'll again do a hydrohalogenation, because we have to, or we must, convert that alkene into an alkyl halide. And after doing that hydrohalogenation, we are going to react this with a strong base. And when we do that, we will get the more substituted alkene. Okay. Actually, I want to show you guys a few more approaches. So let me do something here. Actually, we'll come back to those, okay, which deal with some peroxide effect reactions, but and we'll encounter some of those here. So let's say if I want to go from or convert a more substituted alkyl halide into the less substituted alkyl halide. Okay, so I want to convert a more substituted alkyl halide into a less substituted alkyl halide. So let's imagine a reaction maybe where we have an alkyl halide there, and what I want to do is I want to convert that alkyl halide into that one. Okay, so notice how this alkyl halide is more substituted. Now this is relative to our product, which is less substituted, because this alkyl halide here is tertiary in nature, and this alkyl halide, the product, is only a primary alkyl halide. So whenever you have this sort of a problem, what you're going to do is you're going to first do an elimination. Now you want to eliminate such that you will make a double bond between this more substituted carbon and the carbon where you want to put the bromine at in the product. Okay, so in this particular case, this is going to be a bulky base. So I eliminate there so that I get an alkene. Okay, so notice how I've installed a double bond between the carbon, the tertiary carbon where the bromine was initially connected to, and the primary carbon where I want that bromine in my product. So I make that alkene, and then after this I'm going to do a hydrohalogenation. But if I do a simple hydrohalogenation, the halogen would go back to the more substituted carbon, and I want it to go to the less substituted carbon. So this is where I'm going to use the peroxide effect. So if I bring in some peroxide, the Br would go to the less substituted carbon. So that way I've converted a more substituted carbon or more substituted alkyl halide into the less substituted alkyl halide. Now there's another possibility here, and what you would notice is throughout, it's basically the choice of reagents that matters. By the choice of appropriate reagents, you can convert a starting material into a product that you want to. Okay, so now look at this example here where we have an alkyl halide which is tertiary, and our product is again less substituted. Okay, because it's only a secondary alkyl halide. So we started with a tertiary alkyl halide, which is more substituted relative to our product. And our strategy is going to be the same. We're going to install a double bond between the carbon where the bromine is attached in the reactant and the carbon where we want that bromine in our product, which is that secondary carbon. And so in this particular case, we are going to use a strong base. Now again, the choice of the base, there are several bases that you can use. So I was using sodium methoxide, and I'm going to use sodium methoxide. It is still a strong base which does E2 reaction. So when I do that, I get the double bond here. And the double bond is between the tertiary carbon where the bromine was initially attached and the secondary carbon where I want that bromine to be attached. And now if I do the peroxide effect on this, I will make the product, which is the less substituted alkene compared to my starting material. Okay, so those are some strategies. Again, this is not an exhaustive list, but these are some strategies that are useful. Now let's look at how do you convert an alkene into an alkane. Okay, how would I convert an alkene into an alkane? And sorry, an alkyne, alkene into an alkyne. So let's say that we have an alkene, which is this guy here. Okay, and I want to convert this alkene into an alkyne. So this is a 4-carbon alkene going to a 4-carbon alkyne. Okay, in case the numbering is not clear, 1, 2, 3, 4, and 1, 2, 3, 4. Okay, so 4-carbon alkene becomes an alkyne. Now, whenever you have to do this, the first step in converting an alkene to an alkyne, if you recollect, the bridge or the connecting point between alkenes and alkynes is the halogenation of alkynes. So what we're going to do is we're first going to do a halogenation on this alkene. When I do a halogenation on this alkene, I will get a vicinal dihalide. Okay, so I get a dihalide. And now that I have a dihalide, I can react it with a strong base. Now it's a very specific base, remember that. So sodium amide in excess. And if I quench this reaction with water, I would have made the alkyne. Okay, and now let's say if I want to go from the alkyne that I made to the starting material. This is a one-step process, and recollect this is a terminal alkyne. Okay, this is a terminal alkyne. So in this particular case, I can use hydrogen gas with Lindlar's catalyst, or I can use sodium with ammonia liquid. Either of these two approaches is going to give me the same alkene, because this alkene is a terminal alkene, which means we do not have to worry about cis or trans stereochemistry. Okay, so these are some of the approaches that are useful. We'll discuss some more in upcoming videos.